Hello, welcome to this video. This is 2B-5 and we are going to talk about properties of logarithms. This is a fairly common question on the AP Precalculus exam where we have to deconstruct a logarithm or condense a logarithm. So let's go ahead and check it out. Today we're learning how to rewrite logarithmic expressions, and that's going to involve the properties of logarithms. So you have to know properties of logarithms, and you can use the properties to change the structure of the logarithmic expression. So before we go ahead and jump into the properties of logarithms, a couple of exponent properties that are useful in this just because they will be referenced is the negative exponent property, 1 over a to the power of n. Remember, that's negative n as a power. And then a fractional exponent. The denominator, remember, is a root, and the numerator is a power. So let's go ahead and look at some properties of logarithms and some numerical examples. It's important to note here that for these values, these are any positive values except where the base is not 1 and c is also not equal to 1. So let's go ahead and first reference the power property. The power property of a logarithm says that if I have a power in a logarithmic expression, I can move it out front as a coefficient. And this also works in reverse. If I want to condense this, I can move this coefficient up into the numerator of my argument. That's the power property. And here is a numerical example of this. Log base 5 of 25. Well, if I can make this base 5, I can cancel these logarithms. So 25 is 5 squared, okay, and I can move that 2 to the front, and now I have 2 times log base 5 of 5, okay, which we have this identity property of logarithms that this is just 1. So essentially this is equal to 2. But that is the power property kind of in play. Let's also go ahead and look at the product and the quotient property. Now, when you are adding two logarithms that have the same base, it's very important that you understand that this property only applies to logarithms that are the same base. I can multiply these arguments. So since I'm adding, I can go ahead and multiply those arguments. And here's an example of this. We have log base 2 of 8 plus log base 2 of 4. Well, I can go ahead, I can combine these. This is going to be equal to log base 2 of 32, 8 times 4, 8 times 4, okay? Same idea now with subtraction. This is called the quotient property of logarithms. If I again have the same logarithmic base, I can go ahead and I'm subtracting them. I can divide the first argument by the argument of the second. Okay, so this is log base b of m over n. Let's look again at an example. I have log base 2 of 8 minus log base 2 of 4. Hey, I'm subtracting. I can condense these into 1. So this is going to be log base 2 of 8 over 4. And I don't know why they don't write it here in simplicity, but please add this. This is log base 2 of 8 divided by 4, which then, yes, gives you 2. Okay, so those three right there are your most common logarithmic properties that you are going to use, either to condense, and working from left to right, those are condensing, right? I'm making it into a single logarithm, but sometimes we do it in reverse where we want to expand or open up a logarithm. Now, here's just some other definition-based properties for logarithms. We have first the identity property, log base b of b. That's just 1. These essentially cancel out and give you 1. Log base b of 1 equals 0. Again, remember that's because any base to the power of 0 is equal to 1. And then the last two kind of flow from previous properties. Here I have log base b of m, right, as a power. Again, a couple of ways this works is one that these are inverses and they cancel, the base and the logarithm base. Those cancel, so you just get m. But then two, looking at through the lens of the power property that we just learned, if I move that power, or that exponent out front, we get m times log base b of b. Well, that's 1. So that's how you just get m. Okay? And then two, this kind of idea in reverse, if you have a base of log base b as an exponent, again, these will cancel. Okay? All right. And then we'll come back to change of base property, but there's one last property. Let's go over some strategies in order to rewrite logarithmic expressions. You're going to need the properties, and usually they're in this order. Usually first we'll use the power property of a logarithm. And then once we have that, we'll utilize the product or the quotient properties from left to right. And then we'll go on to definition-based properties if we need them. Okay. Note, the only time you'll use change of base property is when the bases are not the same. So the other properties may be used, or it may be used to help evaluate a logarithm. Okay. Couple of last just kind of vocabulary things before we dive in. There may be two types of logarithms that I will reference. We have what's called a common logarithm, and more importantly, we have the natural logarithm. These are special logarithms that appear often because of their base. Us mathematicians, we like to abbreviate stuff, so we use a simplified notation. The common logarithm is base 10. So whenever you have a log base 10, we don't really write log base 10. You'll just see log of x. So if you ever see log of x, know that it's missing a base, it's base 10. It's implied it's base 10. And if you look on your calculator and you see log of x, if you push this button, depending on your calculator, you may see that base 10 appear. It'll automatically put it, or it won't put it, but it's implied that this is base 10. Okay? That's the common logarithm. The other one is the natural logarithm, and this has base e. Base e. And remember that this is an irrational number, approximately 2.718. And this one looks different. It is a logarithm, log base e, but again, we don't write this. We write ln of x. Y equals ln of x. This is the natural logarithm, or log base e. And it's written ln because it's in Latin. Logarithmus naturale, if I said that right, is how natural logarithm is written or expressed in Latin. Okay, so ln of x, log base e. Let's check it out. They say here, use the properties of logarithms to simplify the expression as much as possible. Show the work that leads to your answer. Okay, let's look at our first example. And the first thing that I am going to do, I see these coefficients out front. I see this 1/2. And I see this 2. So condense this. I'm going to use first the power property of logarithms. I'm going to move them up into the exponent of my argument. So what this gives me is it gives me log of 16 to the power of 1/2 plus log of 5 to the power of 2. Okay? And I like to add parentheses just so I know exactly what's inside of the logarithm argument. And now I can go ahead and I can evaluate these, right? 16 to the power of 1/2. I know that that is 4. This is log of 4 plus log of 25. And notice these logarithms are missing their bases. These are the common logs. These are both base 10. So I now have two logarithms of the same base and I'm adding them. Here is where we are going to use the product property. The product property. Since I'm adding them, I can go ahead and I can express this as a single logarithm, log of 4 times 25. Okay? And so I get log of 100. And for most questions, this would probably be like a multiple choice question. This would be your answer. But this one does have some definition-based properties in it as well. So let's go ahead and look at that. Again, remember that this is the common log, meaning that it is base 10. So I'm going to rewrite this as log base 10 just to help illustrate why I'm doing this. And you notice, isn't 100 a exponential expression of 10, right? That's 10 to the power of 2. So what I'm going to do is I'm going to write this as log base 10 of 10 to the power of 2. And I do this because these two bases, logarithm and exponential, they cancel each other. They're inverses. And so I get an answer of 2. Just 2. Okay? But again, the properties that are important, power property first, usually then followed by a product or a quotient property. Let's look at example number 2. Here's example number 2. No power property to go ahead and utilize here, but what I do have is I have the quotient property. I get 28 divided by 56. Again, this is the quotient property of logarithms, okay? And 28 over 56, that is 1/2, so I can simplify this. I get log base 2 of 1 over 2. And I notice, hey, 1/2 and 2, those are pretty close, so can I rewrite 1/2 as base 2 to simplify this even further? And sure enough, I can. That's 2 to the negative first. So these cancel, and our answer is -1. Pretty cool, right? So those are some examples of how you can rewrite logarithmic expressions. All right. Go ahead. I want you to try this one, and I'll show you the answer here in a second. All right. This one did not have power property to start with. It just went ahead with the product property. I can combine these. Since I'm adding, I'm going to multiply these two values, 3/4 of 12. A couple of ways you can do this. You can divide first, 12 divided by 4. That gives you 3, so you get 3 times 3, or 3 times 12 is 36 divided by 4. Anyway, you get 9 once you find that product, and I have log base 3 of 9. Hey, 9 is 3 squared, so I can rewrite this. This is a definition-based property. These cancel, and you get your answer 2. Did you get it? Hopefully you did. Okay, here is a second practice example, so please again pause me and try this one. All right, in this example, we have log base 5 of 4 to the power of 3. This is the power property. I can take that coefficient and move it into the exponent in the argument of the logarithm. So I get 4 to the power of 3. Well, that's 64, and I'm subtracting here, so this is the quotient property when you subtract. So 64 divided by 64 is 1. Hey, this is an identity. The logarithm of 1, regardless of the base, is 0. Answer is 0. Did you get it? Good job. All right, let's go ahead. Let's look at an example where we have 3. Oh my gosh, I have 3. What do I do? Well, let's start out with the power property first. I'm going to go ahead and I'm going to take these powers and I'm going to move them up and then just kind of clean this up. So I get log base 4 of 2 to the 4th. Plus log base 4 of 27 to the power of 1/3 minus log base 4 of 6, and we can kind of clean this up. I get log base 4 of 8 plus log base 4 of 3 minus log base 4 of 6. Now, couple of ways to do this, depending upon what type of person you are. You can go step by step and work from left to right. Now, if you go from left to right, the first thing that you're going to encounter is the product property. You're going to go ahead and multiply 8 times 3, which will give you 24. Okay, then once you have that, log base 4 of 24, you can subtract log base 4 of 6. You would divide those. Then you would have the quotient property, okay? So you can go step by step in order to do this, but this is also a good multiple choice question where you have to deconstruct, where they want you to expand. So I do want to show this in all in one fell swoop. And pretty much when you're adding, you're going to multiply those together, and when you're subtracting, that's going to be in the denominator. So you see how I have a minus log base 4 of 6. I'm not going to divide these first and then multiply that with that. Although, actually, that may work. But I want to show you this. So I get log base 4 of all of this under one roof. We get 8 times 3, okay, divided by 6. Divided by 6. And sometimes, even going back to my original expression, I just want to show you this. Log base 2 of 4, was that 2 of 4? Why did I write 8? Woo! You guys, it's 16. Why didn't you tell me? 16. So we get 2 to the power of 4. Okay, and then over here, this was 27 to the power of 1/3. So this is a popular AP Precalculus question where they give you this and they say, what's an equivalent way to express this? So deconstruct it. And you have to work backwards. Okay, well, if I'm multiplying, I can separate those into addition. So it looks like this. And then since I'm dividing, that's going to be subtraction. Okay, and then these exponents can go back out front. Right? So two ways that AP Precalculus will ask you to do this. They might ask you to deconstruct in that direction. Okay? Anyway, let's put this in final form here. So I get log base 4 of, I have 16 times 3, which is 48, over 6. Okay? And so I get log base 4 of 8. Log base 4 of 8. Okay, there you go. Now, something that I do want to touch on is our very, very last property, which was the change of base property right here. The change of base property, what happens if I have two values that I can't go ahead and simplify, but they're both families of another base that could be simplified? Well, you can make a new logarithm and choose a new base, okay, as if you rewrite it like this. So log base c of a is equal to log base b of a, so your argument goes into the numerator, divided by log base b of c. Your old logarithmic base goes into the denominator. Okay, so this is your change of base formula, and here's an example of how it would look, right? I have log base 9 of 81. This one you could actually simplify, but aren't they both family 3? So I write log base 3 of 81 divided by log base 3 of 9. This is also useful too before like advanced calculators like TIs. You could, you know, use base 10. You could insert a base 10. So make the logarithm a base 10, and then you could evaluate it with a regular scientific calculator. So let's go ahead and see how this applies to this example that we are working on here. I have log base 4 of 8. Well, those are both, you know, family of 2, right? So I'm going to make log base 2. Log base 2, log base 2. Now, where do these go? Your argument will go into the numerator. Your argument goes into the numerator, and your old logarithmic base goes into the argument of the denominator. Okay, so it's log base 2 of 8 divided by log base 2 of 4. And now I can evaluate this. I get 3 over 2, 3/2, 1.5. There you go. This one right here, maybe you want to add this. This is change of base formula. Change of base formula. Not too commonly used, but sometimes you may see it. Okay, last example I have for you. Here I have a natural log of 10e plus 3 natural log of 2, and I want to go ahead and combine these. So I'm going to use first my power property, natural log of 10e, plus natural log of 2 to the third, which is 8. And I'm going to use my product property. So I have 8 times 10 to the power, 10 times e. 10e times 8. Okay? And I can go ahead, natural log of, this gives me 80e. 80e. Okay, and there's your answer. I can't really do much with it. I guess if I wanted to kind of deconstruct this to simplify, you could. Natural log of 80 plus the natural log of e, right? These are multiplying. And that would give you, this would give you a 1. So another answer here, I guess, would be natural log of 80 plus 1. But I would expect to see this as a final stopping point on the exam. Okay? All right. So that is pretty much it. There are some final practice questions here for you. So I'll go ahead and I'll pause these here for you, and then you can check the response. Okay, here is example 1. We used the power property first, right? I moved that 3 and that 4/3 into the exponent. And then what I went ahead and did was I evaluated these, right? So 2 to the power of 3 is 8, and 8 to the power of 4/3. The third root of 8 is 2. 2 to the 4th gives me 16. And then what I went ahead and did was I rewrote this. Again, I kind of did it in two waves. I went from left to right, and it really matters with subtraction. You don't want to start over here and multiply these and then end up dividing by 32 because that's wrong, actually. So you divide first, and then you multiply by the 2. And so I put them all together in 1. You can kind of see here. When you're multiplying, that's going to go into the numerator. When you're subtracting, that value will be in the denominator. Anyway, 8 times 2 is 16. So 16 over 16 gives us 1. Natural log of 1, 0. Did you get it? All right. Here is next practice one. Please pause. Check this result. Okay, here in this example, again, we use the power property to move those coefficients in, and you got natural log of 2 minus natural log of 4. And then because we were subtracting, we use the quotient property. We divided them. So natural log of 2/4 or natural log of 1/2. Pretty straightforward on that one, okay? Last two practice problems here. Please go ahead, pause this one. Okay, in this example, again, we use the power property. You can see that here. The powers gave us log base 4 of 8 plus log base 4 of 8. We'll multiply those. This is the product property, right? I'm multiplying those because we are adding those two logarithms. We get log base 4 of 64, and 64 is 4 to the power 3. So, hey, I didn't write this, but again, if this helps you kind of see that cancellation, that's 4 to the power 3. Okay, so that gives you 3. All right, last practice one here. Go ahead, try this one. Okay, last example here. You have product property power property for this last one because you 4 to the power of 1/2, which is just 2. And then we can go ahead and condense all of these using the product and quotient property. And so you get 27 as your argument, and then here this is change of base. So you may have stopped here, but this one, if you go ahead and make them both base 3, you can simplify this to get 3/2. Okay. All right. So hopefully in this video you learned how to simplify logarithmic expressions and rewrite them in equivalent forms using properties of logarithms and changing the structure of logarithmic expression. Go ahead, give this video a thumbs up. I'll see you in the next lesson. Peace.